We have free Zoom accounts, so we need to rejoin the meeting.
Can you hear me?
Yes.
Okay.
Just 2 minutes. We're just waiting for the class.
Sorry, why did you use a double quotation, not a single quotation in your X label? Can we use a single quotation?
Single part. What do you mean? One time. Could you just?
Your X label. We have X and predictor, but you used a double.
Double. You mean this one?
Yes. Why didn't we use that?
It doesn't matter. It's the same.
Okay. Because I'm used to one. That's why I'm asking.
It's the same for this case. Okay. Let's continue. We need to add some noise in our points in order to model random deviations from ideal linear dependence. Let's create error, which should be distributed, for example, normally, or it may be also a uniform distribution, but it's in our case, it doesn't matter. We want to add some noise, and let's create it using norm RND function. Let's double click F1. We will read about this function. So this function returns normal random numbers, and we have 3 variants of syntaxes. We need to define mu and sigma. Do you remember what is mean value? I don't need to explain mu and sigma and normal distribution. Would you just say, yes, I know what is it, or no, I don't know what is it, and I need some explanations. What about your background?
I do not know what it is.
Okay, for you, I have additional
value.
Mean value, standard deviation, and random distribution of variable. So
okay, I know what mean value is. Standard deviation, I know, but random, I'm not sure I know that.
Okay, for your additional task for today, read about random normal distribution. I will just just to show you example. Where is it like this? So we have histogram of normal distributed variable. In the center, we will have mean value. It's the most common, it's the, I don't know, the most probable value in these data sets. You just take your data sets. If you have data, for example, 1, 2, 3, 4, and 5, you just calculate sum of these variables and divide it to a number of these observations. It will be mean value. Just
that's the mean.
Yes, it will be mu. We just add some noise to data distributed normally, and we need to select mu value. It will be equal to 0. I will explain it later on. And with some standard deviation, let's select 1, it doesn't matter. And we need to select size. Size will be equal to size of our x variable. Yes, because we need to summarize x array x. It's an array. Yes, we need to define length of x.
Okay.
And let's look x. It's a column or row. X. It's it's a row. So we need to create a row. Yes. It will be 1 row and number of columns will be equal to this. And as I remember, it should be in brackets. Where is it? Yes, in size and brackets. So you see that in examples, okay. 1 row and number of columns will be equal to next. Let's look what we do. We have select this line and press F9. Select and press F9. It runs only 1 line. And you will see in your workspace new variable. Let's open this variable. And you have 1 row, that's good. Select this row, just press to row 1.
Please, you're too fast. You're too fast.
It's fast. Okay. Open this variable. Just double click into workspace. Select the row.
No, actually not even. Can you go back to the code? Yeah, thank you. This one, the length. Sorry, what if we had just used the length of x? It wouldn't give us an array. Is that it?
Length of x is equal to 101.
I mean, like, if we had just used the length of x instead of 1 to the length of x, what difference will it make?
Let's look to this result. It will be square matrix.
Oh, okay.
So you see that when we run this variant, we will have square matrix because we select only 1 dimension. If you need to create, maybe it will be, it also works without brackets. Okay, yeah. So we need to define size.
I'm sorry to interrupt. This F9 thing with this line doesn't seem to work for me. I don't know why.
Maybe you have to press also function because in you are working on laptop or PC?
No. It's like it says unbalanced or unexpected parentheses or bracket. However, my parentheses and brackets.
You need to check your brackets.
Yes. I think
you have an error with brackets. Just check that you have open and close brackets. Opens brackets and close brackets. So we have an error variable. It's really meaningful to control your variables. So you need to understand what do you calculate in each line, and you need to look into your variables because it helps you to detect errors in calculations. Yes, it's really important. So could we just go to the next step? Could you continue? Open your error variable and just go to plot tab and look what do we have here. We may visualize our variables using plots tab and select histogram, for example, here. And we will see that yes, we have our error distributed approximately normally because we have really small amount of observations and our histogram is not ideal. It's a little bit shift to the left, but we have what we have. Okay, it will be our noise. So select this line, select line in error and plot histogram. We will see distribution of our variable. So could we continue?
Sorry, if you could explain that part again.
About plotting histogram.
Yes.
Do you have error variable in your workspace?
If I have what?
Do you have error variable in your workspace? Do you see this variable into your workspace or not?
It's not so clear. I don't know. I'm using phone.
Could you show your screen? I just tried to.
Okay, I can share my screen with you right now.
I stopped my demonstration.
Okay. Sorry, excuse me. Can you see me?
Not now.
Shit, it's actually hanging. I don't know why. Okay.
Can I ask a question?
Yes, of course.
I'm sorry. I want to know what exactly is the use for the understanding of linear regression in the analysis of diseases. I don't know. It will help me to know more about it.
What we just generate test data sets and we model linear dependence between predictor and response, and we will create linear regression model for this data set, and we will see that this model works great. And we also will create data set where connection between response and predictor and response non-linear. And we will see that linear regression model, we may construct linear regression model for the data set, but the results will be not good. And this example gives us understanding what should we analyze in order to understand is linear regression works or not for our current case. So it's like a test set. So Fidel, how are you?
I'm here. It's kind of I don't know what's wrong with this system.
You couldn't share your screen?
I couldn't share. I'm trying to see if I can. Hold on, please.
So new step for other part of our class, please add this variable error to our linear model, to our b0 plus b1 multiplied by x, plus error variable. Add this error to the line and plot the results, and you will see.
Okay, we should add the error to y.
Y, yes.
Okay.
And we will have something like this. You may play with B0, B1, and standard deviation just to see what's going on.
We may what?
You may change standard deviation in order to obtain more random results. So
okay,
this is our linear regression.
Okay.
And also let's add to our plot line linear our original line. Let's divide this y to ln part. Yes. It will be our known dependence and it will be our error. And
makes sense. All right. So let's see.
We just divide our y into linear dependence, non-linear dependence, and error parts. And we will plot it also to the figure. Don't forget to use hold on. Hold on fix allows you to plot several plots in one window without deleting previous one, because if you don't use hold on, it deletes your previous plot. Or we see that we have some we forgot to use x. Yes, that's okay. So Fidel, what about you?
Maybe I kind of lost.
Could you just make print screen of your code and send it to chat? I don't know, is it possible to share?
Okay, I'll try.
The second step.
Show again the can you please show again the scatter command? No, with the O's.
With what one?
The command that shows the O's on the plot.
O's. Scatter plot. It plots circles.
Yeah, thank you.
The it will be our first data set. Yes. And also let's create quadratic dependence between data. It will be the second part. Let's create new section. You may use $% and it divide your script into parts, and you may run them independently. So let's create, it will be with, just want to, we may copy this part actually. and I don't know how it will be better.
Sorry, please, sorry.
Mm-hmm.
When analyzing this graph, we can see that the points are scattered, but it's quite close to the line. So does that show that it's good or it's bad? Is that what is linear regression? It's good.
We will learn linear regression theory in the next week. Unfortunately, we have lecture before or after practice, so you will know information about it later. It's okay. It's good when we have zero mean and our points close to regression line.
Okay. So the closer to the line, the better.
Yeah.
Okay, makes sense. All right.
It means that we have strong relationship between predictor and response.
Okay.
So let's create the second array, but I want you to do, before we go into quadratical, let's look what do we have in our task. We need to save the code of linearity arrays is a function. Yes. So let's create new function.
Sorry, we need to what?
Create new function. New function. And you see the template of the function. You need to change everything here. Function, it's additional file where we just describe how to create lean array. It will be our linear data set, for example. Yes. And as input variables, we will have coefficients, V0, V1, and size of the data set. As an output, we will have X and Y. And let's copy paste our code, this part, to the script. But you see that we want to define size of the data set. Yes, it means that this approach is not suitable for our purpose, and we need to change definition of the X. Try to do it by your own. So change the definition of X in order to you may just define some step, start with 0, yes, and go into an size of an array. Try to create X in such a way that it will be size of n. How to do it? Let's do it by your own, 5 minutes, okay?
Sorry, I don't understand what you're saying.
You need to define X variable when like your predictor with the defined length n. So you need to define not as an example before, like here, because here we couldn't select the length of the array. Yes, here we have standard lengths, But when we create a function, we want to select length of the data set outside of the function. It means that we need to calculate it in some new way. So let's try to do it. It should return x with the length of n.
Oh, I see.
Fidel, what about you? Could you send some image for your code to my email or somewhere in Google Class?
My work is actually very scattered right now. Maybe I would just do it. I didn't do right now. It's very, very scattered. I think I didn't really get it.
Where are you now? Could you repeat? You don't know.
My work is actually very scattered right now. I think I had a fluctuation from my system. I don't know what actually happened. Shut down at that point in time. So I tried to pick it up.
Could you repeat this code?
Yes, I'm trying to repeat it right now.
Okay, try to repeat left part of this part.
Yeah.
Can't we just replace the last, let's say, in x equals to 0, we can just add n instead of the last.
Instead of what?
Instead.
Yes, but it's okay. But you see that in this case you will have really if you have, you may do it. But you will have step 1.
Yeah,
yes.
Yeah. The step will be fixed either way.
Yeah.
You can just choose it's a step.
Yeah.
And choose n and divide it by the step.
Yeah, but also minus step because.
Yeah, -1. Yeah, -1 it will be So n -1.
So it may be like this. Yes.
Yeah.
What if we don't want to start from 0? That's the point. What if we don't want to start from?
We may start not from 0. It's like just an example. We may start with, I don't know, 100. It doesn't matter. But anyway, you may choose not 0. Let's save our function inside our working folder with this name linear dataset. And we will call this function outside the function in our script. Let's copy this line. Copy.
I'm sorry. Your general value of x, is that what we're using?
What do you mean?
X equal to 0 to n minus 1. Is that what we're using, or we should use our own?
You may use your own. For me,
sorry, what I did,
you may use your own.
Is it correct? I used x is equal to size of n. Does that make sense?
No, because n will be equal, for example, 100. If you mean you do something like this?
Yes.
It returns size of variable n. Variable n is 1 value, so size of n will be equal to 1. 1.
Okay.
So you couldn't use it. This function returns size of an array n. Array n has 1 row, 1 column, so size of n will be equal to 1.
Okay. So that doesn't work. Okay.
And let's call this function outside in our script. So we just we just copy paste our code into function because it's really more comfortable to use with functions. And let's run it. And we have some error. Yes, see? Vector must be the same length. I have an error, for example. Yes. And I may go to we don't, because we don't have line Y. Yes. So let's plot line using this equation. You see, I think that you have the same error too, because we had line Y array.
No, I actually fixed it.
Okay.
I used the line Y.
Get lost.
Variable n. Okay.
Sorry.
When you choose this type of generator where we have high values of predictor, you will see that this deviation from the zero will be unmeaningful, and we need to change standard deviation in our noise generator. That's why I prefer small step. I will change here the step.
Oh, okay. I think you have to calm down.
Oh, that's fine. What step size did you use? 0.1.
I want to choose.
I multiplied actually. I multiplied the n with the step.
Yes, yes. But don't forget to
-1 or -1 step.
-1, yeah. And the second step is to create the same function, but for quadratic dependence between x and y. So I want you to do it by your own. Let's create new function.
Sorry, damn.
Okay.
Max value. Quite lost max value.
You've seen that when we select n is really high, we have problems with the deviation. So we need to redefine it a little bit. And I think that this sigma value may also calculate. Maybe. Okay, it doesn't matter.
Okay.
Please write to our chat if you finished this part with function. Write plus if you finished this part to the chat. Harold, no. Where are you now? Ibrahim, we could not hear you, fortunately.
I'm sorry.
Yeah.
Are we using the function in the second part of the code or of the script or the first part?
One more time, please. I just.
Are we executing our functions on the second part of the script or the first part?
We call this function the first part.
We're executing it in the first.
Huh?
We're executing it in the first part. Okay. Is it? Yes. Okay.
Dimitris, okay, I will add code and video. I will load it to our class, and you may repeat it later.
Thank you. I don't think I'm gonna have a problem. I just need to redo it.
Okay.
Thank you.
More CK. Yes. That's level. That's predator. Hey, why? Okay.
So as the result of this first part, we will obtain two scripts. The first script, task 1, contains calling function from the second script and visualize the results of modeling. So we've modeled linear dependencies between two variables, x and y. And at the second part, you need to create the same function, but for quadratical dependence between data sets. I will show you an example, I think, with this quadratic dependence.